Today we're going to talk about the activity series of elements. These are really going to help us out with our single replacement reactions because not every reaction occurs. Just because you put two chemicals together doesn't mean a reaction is going to happen. And this chart, which is part of your chemistry reference tables, will tell us or help us predict whether a reaction is going to happen or not, and help us predict the products, because that's really what we're working towards here. The activity series is a list of elements organized by reactivity. So at the top of the list is the most reactive elements, and at the bottom of the list are the least reactive elements. Like I said before, they're going to help us with single replacement reactions, and they help us predict whether a reaction will occur or not. Each element on the list can replace each element below it. Now that part right there is a pretty important part. So make sure you know that. Each element on the list can replace each element below it. The larger the interval between the elements, the more vigorous the reaction. Okay, what you have in your hands is a copy of what you're going to have in the green chemistry reference tables that you get to use on every single test. Let me get rid of this ink right here. Now, the first thing I want you to do is I want you to take your marker and or your pen, and I want you to draw a line straight across right there where that double line is. That's because there are actually two activity series on here, and they're not to be used together. You have the top one, and that's the activity series for the halogens, and the bottom one is the activity series of metals. You either use one or the other, but never both. Okay, now let's go ahead and look at the activity series of the metals. So we're going to look at the ones on the bottom. Now this over here on the left, I have a list of all the metals that are from top to bottom in that activity series of the metals. Each element on the list can replace each element below it in a single replacement reaction. So your more reactive elements here are lithium and rubidium and potassium. And your least reactive elements are down at the bottom. You got silver, Ag, you got platinum, Pt, and you have gold, which is Au. We use these for jewelry because they're not very reactive. You don't want to start out the day with gold ring on your finger and end the day with gold oxide. It's not worth as much. So let's see how this thing works. The first thing that we're going to do, and I'm going to go ahead and skip to the slideshow here. Okay, so let's look at a particular problem. I have sodium, and then I have zinc chloride. First, we need to determine whether a reaction is going to happen or not. The first thing you do is you need to find that single element. The single element is the one that's not bonded to anything, and that's going to be our sodium, the Na. So we need to find that on our activity series of metals. And then we need to find the metal in the compound. So first find the single element. There's sodium. Then we look on the list and find the metal that is in the compound. There is zinc. If the single element is above the metal in the compound, a reaction will occur. So will a reaction happen here? Yes, sodium is above zinc, and so sodium has enough power to replace zinc. So what's going to happen is that sodium is going to kick zinc off and then bond to chlorine. So here's what it's going to look like. Sodium will replace zinc and bond with chlorine. Zinc will precipitate out. So now what you have to do is write the complete equation with the correct formulas and then balance. So I have sodium plus zinc chloride. Sodium is going to kick zinc off and bond to chlorine. Now we have to do it up here Just like we learned how to write formulas, you have sodium, which is Na positive, chlorine, which is Cl negative. You don't just remove the zinc and put in an Na, because that Cl2 of zinc chloride, that 2 came from zinc. So you have to go back to what their charges are. Na bonded to Cl is going to be NaCl. And zinc is the one who's going home crying. He's the single element that has been replaced. Then, again, you should feel compelled. We need to balance this reaction. So I have 2 chlorines on the reactant side. I have 1 on the product side. So we have to put our coefficients, a 2 in front of NaCl and a 2 in front of Na on the reactant side. Now this equation is nice and neat and balanced. Let's look at another one. What if I have copper and iron 2 nitrate? So what I'm going to do is I'm going to take copper and find it on the list. Oh, it's way down here, not very reactive. Again, we use that for money. We don't want our money changing form on us in the middle of the day, or you forget to take it out of your pocket and then put it in the laundry and it reacts with water or something like that. So we choose low reactive metals for our currency, our jewelry. Now we need to find the metal that's in the compound, and that's going to be iron. It's the first one written. So, will a reaction happen? If the single element is above the metal in the compound, a reaction will occur. Here, copper is below iron. Copper does not have enough power to replace iron. So what has to happen is nothing. They will just sit there. The copper will sit in the solution and will sit there and sit there and sit there and not react. So what you write down is no reaction. That one was kind of fun, and it was pretty easy. Remember that my job is to teach you how to tell whether reaction happens or not, so use this activity series. I also have to teach you how to write reactions. So don't go no reaction crazy on me. There will be some reactions, and probably more reactions than not reactions. So our first tackle is how to read the activity series. The second thing we have to tackle is how to predict those products. Okay, now what we want to do is we want to look at the activity series of the halogens. That's going to be at the top of our activity series chart here that you have. And so that's the one with F2, Cl2, Br2, I2. All right. Each element, it works exactly the same. Each element on the list can replace each element below it in a single replacement reaction. If your single element is a halogen, then you have to use the activity series of the halogens. So that's how you know which one to use. Our first example, I2 plus KCl. We're going to use it the exact same way. We find our single element. Then we find the one in this activity series that the other element. That's going to be the other halogen. Well, you cannot compare it to potassium because potassium is not in this list. So it has to be chlorine. So we find chlorine. There it is. If the single element, which in this case is our iodine, is above chlorine, it can replace it. So will a reaction happen here? No. This is going to be no reaction. Iodine does not have enough power to replace chlorine. What about this one? We've got Cl2, that's my single element, and we're going to react it with a solution of Ki, potassium iodide. Chlorine, our single element, is above iodine, and so it does have enough power to replace it in a single replacement reaction. So what we're going to do here, and the difference between working with the activity series of the halogens and the activity series of the metals, is the activity series of the halogens, or the halogens, are going to replace on the back end of a compound. So let me show you what that looks like. So chlorine is above I2, so a reaction will occur. Chlorine will replace iodine and bond with potassium. I2 will be given off. So we have to write the complete equation with correct formulas and then balance. So chlorine is going to come in here and it is going to kick iodine off. And so now iodine is my single element. And I just go ahead and write that one down. Now potassium is going to bond with chlorine. Again, don't just smack two things together because I taught you how to write formulas correctly. This is ionic. The metal atom goes first, potassium, and then it is going to bond to chlorine, Cl negative. K plus, Cl negative. The formula for potassium chloride is just KCl. So that 2 is not there. Then we just have to balance because it doesn't look right unless we balance it. So I'm going to put, I've got 2 chlorines on the reactant side. I only have 1 on the product side, so I'll put a 2 here. Now I have 2 potassiums on the product side. I need to have 2 potassiums on the reactant side as well. Now I have 2 iodines, and on the product side I have 2 iodines. Okay, so that is the basics of how to work with the activity series. How to work with each one, the activity series of the halogens and the activity series of the metals. So now let's look at some of this other stuff I've completely ignored until now. All these lines that you see on that activity series of the metals. Really, you can kind of look at those as brackets. Okay? Anything from this line, sodium, up, has to deal with this statement right here. Any of these elements can replace hydrogen from cold water. How do you know that water is cold? Well, it's going to be a liquid. So it will be H2O, and this is a cursive L here. Liquid water is considered cold water. So we're going to have to start paying attention to the state of matter that things are in. It's going to become more and more important as we go along. All right. Now I have this in a little bit of detail here. So from sodium up to lithium, each element in this section will replace hydrogen from cold water. So what I'd like for you to do in on your copy of the activity series is I'd like you to take a highlighter or a different colored pen, and I'd like for you to highlight H2O liquid. That way you know if you see a reaction and they're putting something in water, you'll know to look at this part of your activity series. Okay, so let's practice. If I have sodium, that one we may not be able to see so well, so let's try this one. There we go. Oh, that one's a little too big. Let's try that again. Nope, still want to try this one. Na plus H2O, and then we'll have an L here. Will this reaction happen? So you find this single element on your activity series, and you see if it is within this category of elements. We see that it is. Sodium does react with cold water. So what does it do? Well, we have this on your activity series, and here, it's in my handwriting. And I say when these metals react with water, they form a metal hydroxide and hydrogen gas. So what I want you to do again with your highlighter or your different colored pen, I want you to highlight metal hydroxide. Now hydroxide, that's OH negative. If you need to write OH negative there beside it, please do so. Might be a good reminder. And hydrogen gas. So it's going to produce those two things, and then we'll be able to complete the reaction. So let's go back to that particular problem. I think it's here. There we go. And let's try this again. So, sodium plus H2O liquid is going to react. So we do have a reaction here. And what it's going to form is a metal hydroxide. What metal? Well, the only metal we have here, sodium. Things can't come out of nowhere. So sodium. And then notice I'm writing this above the arrow so I can do, it's kind of like your scratch work. Sodium is Na positive, and a metal hydroxide. Hydroxide's OH negative. So that's NaOH plus, so it's also going to give off hydrogen gas. Hydrogen is diatomic, and so it has to be H2. Don't forget about that. Then, again, you should feel compelled to balance this equation. So I have, let's see, let's look at our oxygens. We're good on that. It's just our hydrogens that are out of whack. I need to put a 2 here. That's going to give me an even number of hydrogen. It's going to be easier to replace on this side. So I have 2 NaOHs. So that means I need 2 NAs on this side, on the reactant side. I have 2 oxygens. I only have 1 on the reactant side. So I need to put a 2 here. That means I have 4 hydrogens on the reactant side. I have 2 here and 2 NH2.